terminology. There's a lot of like terms that people around databases like to throw around, and hopefully we can demystify some of them. Sometimes it's hard for me to even know what terms I'm using because I'm so used to hearing them so frequently. So if I'm saying words that you don't understand, just stop me so that we can make sure that everyone gets these. So database is really just a repository of data, right? Like if you can imagine like in a program that you're writing, you have like an object that stores like your state, like a Redux store or something like that, right? This is basically that, just on a much, much larger scale. So instead of storing 100 things, you're storing 1,000,000 things, 1,000,000,000 things, right? That's what databases can do. These are meant to be giant scale things that can scale across the entire world, that can have, resiliency and store very important things on it, right? Like that's what databases are for. What's fun about them is that there's a variety of different ways that they can work, and it depends on what you want them to do. So that's what I'm going to teach you here. I'm going to teach you 4 different kinds of databases. That's why I chose these 4 different databases that we're going to be looking at today, is because these are exemplary of different types of databases. It's actually funny, I was working with our artist to kind of come up with like this, this picture here. And she was like, can you explain to me a little bit what a database is? And I came up with this analogy, and then she loved it so much she actually put it into the artwork. And I asked her, like, what's the best way to get from point A to point B if that's only a mile away? If you have a bicycle, you have a car, you have a boat, and you have like a airplane, right? Well, I think the answer is it really depends what's in between the two, right? Like if you're trying to get from one side of Amsterdam to the other, having a Ferrari is not going to help you very much, right? That city is so jam-packed, but having a bike is going to be the best thing you could ever want, right? But if you're trying to get from like point A to point B and it's in the middle of the ocean, you probably want a boat, right? And so it depends on like your job requirement of which vehicle you're going to choose. And that's kind of the same thing here with databases. They're all going to get you from point A to point B, but one of them is going to be significantly better for the problem that you have, right? Does that kind of make sense? So you can see here, she kind of ran with that. There's like a Neo4j hot air balloon, there's a Redis car, there's a MongoDB boat, and there's an elephant because everyone likes Postgres elephants. Okay. So that's kind of why we have all these different kinds of databases, is because they're going to work better for different kind of things. So when you have these like massive stores of data and you want to be able to get certain resources out or update or delete certain things, you need some sort of query language, right? Some thing that you can hand to it and say, here's an action that I would like to take. And so all of these databases have various different forms of query languages that we're going to have to learn. So you're actually going to end up learning 4 different query languages today, but most of them are intuitive enough that you should be able to pick them up pretty quickly. Okay, so that's a database. It's a repository for lots of data. And then that's another good term to pick out of there is query, where I'm going to be using that term a lot. It's basically just something that you're going to send to a database, some action or request or something like that. That's a query. Another good one to know is schemas. So a schema is basically what's the shape of your data look like, right? So I have put an object in here. If I have this object here that says name, city, and state, the schema of that data would be the name and the city and state. So I could have 5 different objects and they would all have the same schema. They would all have name, city, and state, despite the fact that the values of those would be different. The keys would always be the same. Another good way of thinking about that is like, think of like a spreadsheet, like Excel or Numbers or something like that. The columns would be the schema of your Excel spreadsheet. And you'll notice I'm going to refer to spreadsheets a lot during this course. It's because a spreadsheet is a database, right? Of some variety, it's a way of storing data in a structured fashion. It's a database. I've actually seen way too many people use like Google Sheets directly as a database, so it's actually possible to use a spreadsheet as one. Not suggesting it, not teaching it, but it is possible. So schemas are important because some databases like Postgres are going to require us to be very strict about our schema. We're going to have to tell Postgres up front, here's every key that I will ever give you. And if you try and give it another key, it's going to be like, I don't know what to do with that, and that just fails the entire query altogether, right? And you can contrast it against Mongo. Mongo's going to be like, give me whatever you want. I don't care. It's schemaless, right? So we'll get more into that. But that's a word that you'll hear me throw around a lot in this course as well, which is schema. We're going to be talking about document, relational, graph, and key value store databases throughout this course. But I wanted to let you know that there are actually a lot more than just those four. Those four might cover maybe, I'm going to guess, 90% of use cases, but there are a lot of other ones as well that you should know about. One of them is search engines, not like Google, but more like something called like Solr, or Sphinx is another one that's really popular, that allows you to basically create like a search engine for your database. So a lot of these databases don't have the ability to do what's called full text search, which is to say, here is 3 words. I want to search for local beer inside of my database, but it needs to span across all of the different columns. You'd use something like a search engine to do that. Some of them had that ability just built in, like Postgres and MongoDB do, but some don't, so you'd use a search engine. Another one is called wide column databases. These are a fairly new type of database. If you've heard of, Google's Bigtable. Google's Bigtable is kind of the famous version of a wide column database. Another one is Apache Cassandra, which is actually grew out of Facebook and how Facebook stores all of their data. I don't really totally get how to use them, so I'm not going to spend a ton of time, but it's described as a 2-dimensional key value store, and if that doesn't mean anything to you, it doesn't mean anything to me. So, but that's how they describe it. Message brokers. I actually might come back and do another course sometime on message brokers because I think it's really important and really cool. This is going to be somethsomething like Kafka or RabbitMQ. It's the ability to pass messages between your programs. I think it's really underutilized by Node developers because it really is conducive to how to write Node apps. And then another one's called multi-model databases, which is basically a database that knows how to act like maybe both as a relational and a non-relational database at the same time. A good one is Azure Cosmos DB. That's the one that I work a lot with, obviously, because it's in Azure. But another one would be like a RangoDB. Those are multi-paradigm because they can work in different ways. That's not all of them as well, but that's probably like 95% of them now that I've described to you. But just go look at the Wikipedia article of databases. You'll see that there's a ton of types of databases. ACID, let's talk about that one for a little bit. So it's an acronym that gets thrown around a lot as databases, and I just wanted to make sure that you understand why that gets thrown around. It stands for atomicity, I think is how you say that, or the atomic nature of databases, consistency, isolation, and durability. And it's kind of like the qualities that a database can have. Not all of the databases that we're going to be looking at today have that, and some of them do, but you need to understand like the trade-offs that you're making when you choose one of these databases. So the first one, atomicity, is does this query happen all at once? So it's atomic in nature, so it means you literally cannot divide the query into multiple parts. It is a single query. That's important for things like, you can imagine bank transactions, right? If I'm going to subtract $10 from my account and add $10 to your account, you want that to be one transaction, because if that happens in multiple transactions, that means what happens if one happens and then the server goes down? It means someone lost $10 and someone didn't gain $10, so it means you lost $10 altogether, right? So you need that to be an atomic transaction where the loss of $10 here and the gaining of $10 here is all one atomic transaction. Does that make sense? It ends up being extremely important. These are called transactions. So yeah, that's really important. You'll see down here, we'll talk about transactions again as well. The next one is consistency. A good example is you'll always have multiple database servers running at the same time. So if I have 5 database servers go down and if I have 5 running and I have 1 go down, the other 4 need to kind of pick up the slack. And if your database isn't consistent, that means that they're going to be out of whack a little bit, so you don't actually know which one knows the truth. And even worse, you might actually lose data. So if your main database goes down and you have 4 others and they're lagging behind the main one, that means you could lose data in the process, which again, for like banking stuff, that's a disaster, right? Someone could be losing millions of dollars just because your database went down at a bad time. You'll notice a lot of these times I frame this in terms of money. It's because banks have been really driving databases for like the past 50 years, right? So a lot of these features exist because banks have made them that way. Isolation. Isolation is just kind of, we don't necessarily talk about this one as much, but if you have a query that's going to be doing a bunch of things all at once, it basically means that you can run them concurrently. So you can run like the transaction broken down into pieces all at the same time, or you can run it serially. So this one, do this one, then this one, then this one, right? And everything will happen the same way. So it just basically means you can decompose it into parts, run it in different parts, and that's still going to work okay. And then lastly, durability. That just says if your server crashes, that you can restore it back to where it was, right? And that just means that it's writing to disk successfully, and it means your data is durable to a crash. Okay, so that's ACID. So if you hear a database described as ACID, or if you hear a query is described as being ACID, that's what it means. It means all of those boxes are being checked. So you might be thinking right now, is like, well, I want everything to be ACID, right? Like I want everything to be totally, done in this way. But the thing is, you're making a trade-off, right? ACID is safe, but it's slow. Like if you're reading through these, something like durability, it means if your query is durable, it means that it's not only writing to the main server, but it's actually going to be writing out to all of the other servers, and they're all going to be writing to disk. And you're going to have to wait for all of that stuff to happen before the query is marked as successful. That is very slow, particularly if your database is spread across the entire world, right? So instead of waiting 5 milliseconds, you're now waiting 2 seconds for your query to totally complete. That might be worth it, again, if you're moving money around. But if you're just updating a profile picture, it's probably okay if that's not totally consistent and totally durable, right? There's acceptable loss in data. So that's what I'm just saying is know trade-offs that you're making, know which data is acceptable to lose, know what data is totally unacceptable to lose, and you're going to have to make choices on databases based on that. Transactions, the one I just wanted to call this out specifically. Sometimes one query can't accomplish all the things that you want to do, so you're going to have to send multiple queries to accomplish the thing that you want to do. But again, you can't break it up. Most of these databases, in fact, I think all of these databases allow the ability to do transactions, which is I'm going to send you 5 queries, but I just don't want you to do anything else besides those 5 queries, right? So it actually makes those 5 queries act as one query, and that's considered a transaction. And you're just guaranteeing this either all happens or none of it happens, because I can't have it partially happen, right? Which, going back to the money thing, if you're going to take $10 from this account, you must add it to this account. Don't do anything in the middle. I can't have that inconsistency in my queries. If you have a multi-threaded database and you're sending a query that can be broken down into multiple threads, that query needs to work the same way in parallel than if it ran sequentially, which basically just means this query needs to work the same way every single time, no matter what you send it. Like, no matter how the database is processing it, the query needs to work the same way. That's probably a better way of putting it. To be frank, I don't really understand isolation as much because it's not something you ever talk about. It used to be important, and now basically everything checks that box.
So transactions only relate to ACID compatible databases?
No, transactions relate to almost every database. It's how databases get around the problem of I have a thing that must be atomic, but I don't have the ability to do this in one query, right? It's like I have to say this idea in one sentence, but I have the grammar structure doesn't allow me to do it in one sentence. Therefore, I'm going to be using semicolons to get this into one sentence. Does that kind of make sense? So it's related to the A. I guess you would use it to fulfill the A. Yeah, okay, I guess they are kind of tied to each other.